make that 3 months. Okay, you're gonna make me. No, I did not mean baby. I mean, they completely demolished my body of knowledge. I was an expert on anything LIBOR related. So 575 is the 6-month yield. Okay. So let's calculate cost of option one. I need $1 million 3 months from now. But I'm going to borrow some amount now. So borrow $X and deposit that at the 3-month rate. Obviously, unless that rate is zero, I shouldn't be borrowing 1 million because I'm going to deposit that money and gain interest. Of course, if I get that multiplied with 1 plus rate 3 months, and I'm going to divide that by 4. Remember, these are APR numbers. Technically speaking, 91,365. Okay. But that's close enough to 4. I'm going to divide that by 4. The rate that you get is an APR, annual percentage rate. Actual interest that you get, you divide that APR by number of periods, 3-month periods you have in a year. And I want that to be $1 million. Obviously, X is equal to present value of 1 million at the 3-month rate. Hence, I'm going to actually use this one, 1 million divided by 1 plus 5.55% divided by 4. Let me zoom a little bit. Hence, I need to borrow $986,314.88, right? I will pay this loan back in 6 months. So pay uh, 986,314.88 times 6-month rate divided by 2. That are 2 6-month periods in a year. Let me write it here. 986,314.88 times 5.75% divided by 2. That means I will pay actually, let's calculate. Let me get rid of this. I'm going to eventually do these in Excel, but I want you to guys see where this comes from. 986,314,88 times 1 plus 5.70. Just so that I can. So I'm going to pay 1,014,671 and 40 cents. So basically, the 3-month cost of doing it this way is 14,671.40. Okay, or the 3-month rate from option one. Hmm? But I didn't borrow $1 million. Remember, borrowing 6 months, borrowing 986 something. If I, yeah, right now allowed me to have $1 million 3 months from now. So I'm thinking about the cost from that point. Okay, I did something that's gonna get me the $1 million 3 months from now. So on top of that 1 million that I'm gonna pay back, I also paid 14,671 in interest. So I'm concerned about the interest just for that portion. Okay? Or the interest rate would be 0.0146714 times 4. So that's, remember that 1.46% is for the 3-month period. We always convert it into APR. So 5.8684%. So per $1 that I need 3 months from now, the appropriate interest rate for the second 3 months is 586.84 if I do it using option one. That means option 3 should cost the same amount. If it doesn't, there is arbitrage to be made. And for example, suppose option 3 cost 5.75%. Okay, obviously that's cheaper, right? You can see how you can make money. You're gonna go to a bank, and bank tells you that they're gonna lend you for the second 3 months at 5.75%. You're gonna say, okay, I'll borrow from you. Then you're gonna go ahead and do the reverse on the money market. You're gonna basically deposit money for 6 months, withdraw it back 3 months from that day, and pay back that loan. Okay, you will actually make money without taking any risk. I'm This is not the course to go over that arbitrage argument, so I'm not going to, but know that you can make money, right? So in general, if you think about it, the way we calculated that rate, we started with our principal. I'm going to call that dollar $n. Sometimes that's called a notional amount. I took dollar $n and let me do this. I divide that by PV factor for 3 months, where PV3 is 1 plus R3 over 4. And I apply the PV factor for 6 months. I'm writing it this way because when the terms change, all we have to do is calculate those PV factors. And I gonna pay back dollar $n, right? In fact, dollar $n is pretty much the same. So times 4 in this case. Okay. Or that's the cost of what you want to call second part of the time frame.